If the photon of wavelength 150 picometer strikes an atom and one of its inner bound electrons is ejected out, not surface one, with a velocity of so much, calculate the energy with which it is bound to the nucleus. Well, very, very interesting. I have energy of incident radiation is 150 picometer, right? And it is striking not a crystal but just an atom, fine. And kinetic energy of ejected photoelectron is not kinetic, it's velocity. This is half mv square and v is 1.5 into 10 raised to 7 meters per second, very high, very, very high. Calculate the energy with which it is bound to the nucleus. The concept is very similar to photoelectric effect, although instead of metal crystal, it is being applied to an atom. How do we first use common sense and derive our equation? It is E incident photon. This is the energy of photon which came in minus energy with which electron is bound to nucleus, or the binding energy of electron. This is equal to Ke of ejected electron, right? Incident photon hc by lambda minus energy bound, this we have to calculate, is half mv square. Mass of electron I know, velocity of electron I have been given. I just have to substitute and I will get the binding energy. How do I do that? Let me do that for you. It is, first of all, let's just calculate them one by one. Units you can choose, will it be electron volts or will it be joules? I prefer on an atomic number scale. I mean, if you're dealing with atoms, molecules, photons, electron volts is a much more convenient unit. We can take that. So E incident hc by lambda, which is 12424 electron volt angstrom units by, what do we have? We have 150 picometer, that means 1.5 angstrom units. This cancels off. I'll get something, I'll get a number. So many electron volts, and this is going to be very huge. How much? Well, this would be 12424, 24, 15 8s are 120, 42, 15 3s are, no sorry, 15 2s are 30, 124, 15 8s are 120, 40, 15, roughly 3. So 12424, 12,000 comes to be roughly. This is roughly what you get. It is 2.67 whatever, you get 82, 83 electron volts nearly. This is the energy of photon which is striking the atom. Kinetic energy, yes, it goes out with this kinetic energy. How much is this? Ke is half mv square 9.1 into 10 raised to minus 31 kg into velocity. Let us square it. 1.5 square is 2.25 into 10 raised to 14 meter square per second square. Huge, huge, huge. Not that huge actually. This is in joules. If you wish to convert this to electron volts, yes, 9.1 into 2.25 by 2 into 1.6. 31 minus 14 would be 10 raised to minus 17 divided by 10 raised to minus 19. So many electron volts. Oh my God. Can we calculate that? Yes, why not? Yes, we shall. And yes, we can. Something into, what is that something? We'll need to calculate that, of course, into 10 raised to 2 electron volts. Can we have an approximate number? We can. But why go for approximation when it can be more accurate? We'll do that. 6.4, this would give you, or this is around 640 electron volt. Well, 640 is what you have to subtract 3 out of this 4, 6, 76, 43 electron volts. This is a rough number which comes out. In case we do a more accurate calculation, maybe a little difference of that 32, 43, around 11 electron volts, we can sort it out. So these are the answers, very close. I mean, you might feel that there's a little difference. Percentage difference is very small, reasonably accurate, a beautiful answer.